All right, this is Professor Pelton. This is part 1 of chapter 5, section 2. So now we're going to cover power functions, or more specifically, polynomial functions. So a power function is something that's like x to some number, and it can have a constant k out front, right? So things that are not power functions are like, I don't know, anything that's trig, right? Those would not be power functions. Anything that's logarithmic, I don't know, 6 to the x, that's not a power function. If the base number itself, and again, we can have like 7 to the x, right? If the base number is a constant and the variable is an exponent, that's not a power function either. It's actually called exponential. All right, and that's not the only thing. There are many different types of functions that are not specifically power functions. So a specific category of power functions is polynomial functions. So those are the ones that are going to have whole number exponents, right? So if this is an 8, then that's a 7, that's a 6, all the way down to dot, 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 1 and 0. It doesn't have to have every single term, but they're defined by their highest term essentially, and then they have constants out front, which could be any real number essentially. All right, so standard form is when they are in descending order essentially. And the highest degreed term determines what type and name of the polynomial that it is essentially. Okay, so let's do some basic examples. So if it's a degree 0, that is known as a constant. So the standard form would be like y equals a sub 0 x to the 0, or something like y equals 5. That would be a constant function. So first power is known as linear. So y equals a sub 1 x1 plus a sub 0 x0. So that could be like something like y equals 2x minus 3. That's a linear function. So second power is called quadratic. So y equals a sub 2 x squared plus a sub 1 x1 plus a sub 0 x0. So that could be like y equals 5x squared minus 3x plus 1. Okay. And then third power is known as cubic. You don't have to have every single term. I can skip terms, right? So y equals a sub 3 x to the 3 plus a sub 0 x to the 0, right? Actually, if we're going to write standard form, we shouldn't skip any. To the third plus dot, 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 right? There's a pattern in between. A sub 0 x 0. So that could be like y equals 7x to the third minus x plus 8, right? You don't have to have that second powered term. You can skip the other terms. The only one that matters is the highest one. So fourth power is called quartic, right? So y equals a sub 4 x to the 4 plus dot, dot, dot plus a sub 0 x to the 0. So y equals, I don't know, how about negative 3x to the 4th plus 2, right? So I skipped all of the terms. I didn't put a third power, second power, or a first power term on there, which is fine. You can put all, some, or none of them. The only thing that matters is the highest one is the fourth power, right? So you just call this the nth power. After that, there are other names. We're not going to go through them though, right? So y equals a sub n x to the n plus dot, 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 all the way down to the 0 power again, right? I'm not, I'm not going to put an example there because it's just arbitrary. Okay, so the question is, are the following actually polynomials or not? Okay, all right. Determine the following are polynomials. If it is not a polynomial, why? Otherwise, write it in standard form and state the type. So the first one, yes. So this would be f of y equals 12y to the third plus 4y squared minus 9y plus 6. Should probably be consistent with my y's. I'm making all sorts of different y's. So I put them in descending order. So this is a cubic polynomial, right? They're all nice whole number exponents, and it's a power function. So this one is not a polynomial, not a polynomial, right? decimal exponent. So it's a power function, but it's not specifically a polynomial. So the next one is a linear polynomial, right? So the next one is not a polynomial, right? We have a fractional exponent because we know that a square root is a half power, correct? Right? So this is the same as saying 2x plus 3 to the half power. And fractions and decimals are not polynomials. Okay, and the next one is not a polynomial because you think about this is negative 3x and negative 2. So not a polynomial. Negative exponent. Okay, maybe a lot of people will say, oh, the root 2 is a problem. No, the constants in front can be anything that you want, the coefficients, but the exponents themselves can't be negative or decimals or fractions. That's the problem. So each of those three non-examples are power functions, but they're not specifically polynomial functions. All right, pause the video and try the next page for yourself. Okay, so if we go through these, are they polynomials? The first one, yes. This is f of x, 2/3 x to the 5th plus 3/7 x squared. So that's a 5th power polynomial. There are names after 4, but we're not going to bother covering those. Okay, so the next one is not a polynomial, right? It has a negative exponent. Those do not fall into there. It's a power function, negative exponent. All right, so the next one is actually fine. So I put it in actual correct order. So I get f of x equals negative 4, negative 1 times x to the 4th power plus root 3 x squared minus 7. So that is a quartic polynomial. Okay. And the last one is not a polynomial, not a polynomial, right? Fractional exponent is not good. It's a power function, fractional exponent, but it's not a polynomial specifically. Okay, that is the end of part 1.